I'm Ajay and I'll be your pactor for Introduction to Quadratic Equations. Quadratic equations is possibly one of the most important fundamental topics which summarizes your learning of basic algebra. We'll be using the Wahpact, that is, what, why, when, where, who, and how to complete our journey of quadratic equations and make you feel at home with the basic concepts. The objective is to develop the approach towards identifying, solving, and analyzing the quadratic equations. Let's start with some facts. The assumption is that you have a good understanding about these facts. An equation is a statement of equality containing one or more variables denoted by an equal sign. Algebraic expression is a combination of constants and variables connected by algebraic operators, which are addition, subtraction, multiplication, and division. Exponent is the power to which a number, symbol, or expression is to be raised. Simpler way could be the number of times the same number, symbol, or expression is multiplied by itself. The number of times is called the exponent, or often termed as raised to the power. For example, 2 raised to the power of 3 would mean 2 multiplied by 2, again multiplied by 2, that is, 2 multiplied by itself 3 times. Independent product of factors present in expressions is called term. Example, in the expression 3x squared plus 4x plus 5, the terms are 3x squared, 4x and 5. The numerical part of each term is called the coefficient in the term. In the above example, we have 3, 4 and 5 as the coefficients of the respective terms. The assumption is that you are aware about the algebraic identities. Polynomial is an expression containing one or more terms with non-zero coefficients and variables having non-negative integer exponents. X squared, 4x cubed plus 2x plus 3, 5x plus 4 are all polynomials, but x squared plus x raised to the power of root 2 or 4x plus x raised to the power of minus 1 or x raised to the power of 1 by 2 are not polynomials. Degree of a term is the sum of the exponents of the variables. Example, x squared has a degree 2. X squared multiplied by y squared has a degree 4 and x squared y cubed z cubed has a degree 8, and the assumption is that x, y and z are all variables here. Degree of a polynomial is the highest value of a degree in all the terms of the polynomial. Example, x cubed plus 3x plus 1 has a degree 3, whereas x cubed plus 3xy cubed plus 1 has a degree 4, where we have again the assumption that x and y are variables. Algebraic expression and algebraic equation are very different terms. So I hope that you understand there is a lot of difference when we use algebraic expression or we suggest algebraic equation. So let's start our journey of quadratic equations. But before that, let's look at what is quadratic. Quadratic comes from the word quadrate, meaning made square. Quadratic in this reference means involving the second and no higher power of the assumed variable. For example, x squared would be quadratic, but x cubed or x raised to the power of 4 would not be quadratic. Now that we have understood what is quadratic, let's apply the same understanding to quadratic equations. So, what is quadratic equation? Quadratic equation in the variable x is an equation of the form ax squared plus bx plus c is equal to 0, where a, B, and C are all real numbers and A is not equal to 0. Some examples are given here. Here we can see that in all these quadratic equations, the term where degree is x squared, the coefficient is not 0, and A, B, and C are all real numbers. Now that we have a feeling of quadratic equation, let's see how to identify the quadratic equation. The conditions to identify are as follows. It should be a quadratic polynomial in one variable and it should be equated to 0. Quadratic polynomial was part of the fact, remember? The degree of the quadratic polynomial should be exactly equal to 2. All coefficient values of all terms should be real numbers. And the coefficient of the term with exponent value of the variable as 2 should not be equal to 0. All these conditions become ax squared plus bx plus c is equal to 0, where a, b, and c are all real numbers and a is not equal to 0. So let's take 4 examples and see if the equations qualify to be quadratic equations or not. Let's take the first one. X plus 3 as a whole cube is equal to x cube minus 4. On simplification, we have x cube plus 9x squared plus 27x plus 27 is equal to x cube minus 4. Cancelling x cube from both sides, we have 9x squared plus 27x plus 31 is equal to 0. As the highest degree is 2 and the coefficient is 9, this is a quadratic equation and we can see it satisfies all the conditions. Let's take the second example. X multiplied by x plus 2 plus 5 is equal to x minus 3 as a whole multiplied by x plus 3 as a whole. On simplification, we have x squared plus 2x plus 5 is equal to x squared minus 9. If we cancel out x squared from both sides, we have 2x plus 14 is equal to 0. As the highest degree of x is 1, so this is not a quadratic equation. Let's look at the third example. X minus 3 whole square minus 1 is equal to 2x plus 1. On simplification further, we have x squared minus 6x plus 9 is equal to 2x plus 1, which finally becomes x squared minus 8x plus 8 is equal to 0. I hope you see the pattern emerging with the conditions, as the highest degree here also is 2. So this qualifies to be a quadratic equation. Let's look at the last example. X multiplied by 3x plus 2 as a whole is equal to 2x squared plus 4. On simplification further, we have 3x squared plus 2x is equal to 2x squared plus 4. If we simplify it further, we get x squared plus 2x minus 4 is equal to 0. And this also qualifies to be a quadratic equation, as it satisfies all the conditions. It's great that we have learned to identify whether an equation is quadratic equation or not. But a very basic question is, why do we study quadratic equations? Answer to why we study the quadratic equation is hidden in the word pattern recognition. The study of quadratic equation acts as an important tool in deciding and actually solving real-life problems. Let's see how to convert simple word problems to a quadratic equation. The area of a rectangle is 360 meters square. The length of a rectangle is 2 meters more than the width. What is the length and width of the rectangle? So let's take x as the width so that length becomes x plus 2. Now it's given that area of the rectangle is equal to length into width. So we have x plus 2 multiplied by x, which is equal to 360 meters square. As we can see on simplification, this becomes x squared plus 2x minus 360 is equal to 0, which actually is a quadratic equation. Let's look at another problem. The product of two consecutive even numbers is 360. We need to find the numbers. So say if one number is x, the second consecutive even number would be x plus 2, and their multiplication is equal to 360. So we have x multiplied by x plus 2 as a whole is equal to 360, which implies that x squared plus 2x minus 360 is equal to 0. Interesting that the word problems were so different, but they ended up as the exact same quadratic equation. So in essence, if we learn how to solve the quadratic equation, we would be able to provide the exact value of length and width in one question and solve for the product of two consecutive even numbers in another question. It's like many roads lead to one final destination, that is, solving a quadratic equation. Let's move to the next logical question, that is, how to solve quadratic equation. Quadratic equations can be solved by many methods, namely factorization method, completing the square method, and quadratic formula. In general, you may be asked to solve a quadratic equation by one of the methods. So understanding all methods is important. Even the identification which method is applied at what scenario would require some experience. Before we explore these methods, we should be clear about few terms which are related to quadratic equations. Roots. For any real number, say alpha, which satisfies a quadratic equation, ax squared plus bx plus c is equal to 0, where a is not equal to 0, such that when alpha is replaced with x, satisfies the equation a alpha squared plus b alpha plus c is equal to 0, is called its root. In essence, we are just replacing x with alpha, and that is actually satisfying the equation. Next term is solution. All roots can be expressed as solution. So if alpha is a root of the quadratic equation, x is equal to alpha is a solution of the quadratic equation also. And the final term that we often hear is zeros. Quadratic equation has nothing to do with zeros. Zeros are there for polynomials. I know, this was a tricky one. Zeros can be described much better in a way for what value of variable x will the polynomial value be equal to 0, and that value of x is called its zeros. So let's start our journey how to solve quadratic equations with what is factorization method. Factorization method is also called splitting the middle term. It is best understood with an example. So let's say we have a quadratic equation x squared minus 5x plus 6 is equal to 0. So we split the middle term and we have x squared minus 2x minus 3x plus 6 is equal to 0. Here we can take x as common and we have x minus 2 as a whole multiplied by x minus 3 as a whole is equal to 0. And we infer that x minus 2 is equal to 0 or x minus 3 is equal to 0, which implies either x is equal to 2 or x is equal to 3. These form the roots of the quadratic equation. A quadratic equation always has two roots in the above equation. X is equal to 2 and x is equal to 3 are the roots of the quadratic equation x squared minus 5x plus 6 is equal to 0. 2 and 3 are also the solutions for the quadratic equation. Let's take another example. 4x squared minus 4x plus 1 is equal to 0. We split the middle term again. We have 4x squared minus 2x plus 1 is equal to 0. Once we simplify it further, we have 2x minus 1 whole square is equal to 0, which gives us x is equal to 1 by 2. A quadratic equation always has two roots, but in this scenario, the roots are identical. So the equation 4x squared minus 4x plus 1 is equal to 0 has two roots, half and half. This is how we represent roots and one solution only, which is half. The fundamental rule of how to split the middle term lies in the following steps. For a quadratic equation of the form ax squared plus bx plus c is equal to 0, where a is not equal to 0 and a, b and c are real numbers, we calculate the product of a multiplied by c. Take the factors of the product of a multiplied by c and add the factors. If the addition of factors gives the middle term, that is the way one should split the middle term. Let's take an example. 2x squared plus x minus 300 is equal to 0. Step 1 is 2 multiplied by minus 300, which is equal to minus 600. Step 2, there can be many factors of minus 600, but the addition of 25 and minus 24 gives us 1. This will give us the middle term, and this is how we need to split the middle term. So we have, splitting the middle term, the equation has 2x squared plus 25x minus 24x minus 300 is equal to 0. Solving this, we get x is equal to 12 or x is equal to minus 12.5. So let's continue with the second method, that is, what is completing the square method. Solving a quadratic equation by converting the equation into perfect squares is called completing the square method. The basic knowledge of algebraic identities helps a lot in understanding this method. Let's consider a word problem to understand this method. The product of Rita's age 3 years ago and her age 4 years after from now is 13 more than her present age. What is her present age? Oh, I know it sounds confusing, but it's actually very simple. Assuming the current age being x, the product of the ages 3 years ago and 4 years later is equal to x minus 3 as a whole multiplied by x plus 4. So on further simplification, we have x minus 3 as a whole multiplied by x plus 4 is equal to x plus 13. And further simplification, we have x squared plus x minus 12 is equal to x plus 13. This implies that x squared is actually equal to 25. And now we can apply the algebraic identity a squared minus b squared. The values of x is equal to plus 5 or minus 5. As age cannot be negative, the acceptable answer is plus 5. This is good, but what if the final quadratic equation is not a perfect square? Let's take a simple example. X squared plus 2x minus 8 is equal to 0. We'll solve it with the completing the square method. A pictographic version is actually shown. So we have a square of side x symbolizing x squared. Then we can have two unit width rectangle with length as x, and then we have 8 squares of each unit length 1. Here, if we use our imagination, we can just take the side which is x squared and add both the rectangles to its two sides of the square and just add 1 unit of square. This makes it perfect square of x plus 1 whole square. Interesting. But we still have 8 unit blocks remaining with us. And then the one additional block that we just added also has to be subtracted. Thus, adding 1 to 8, making it 9, which is also a perfect square. This gives us 9 unit blocks, which actually is 3 square. So here also we see that completing the square method requires imagination with numbers to solve. At a generic level, for solving a quadratic equation, that is ax squared plus bx plus c is equal to 0, where a is not equal to 0 and a, b and c are real numbers, by completing the square method, the following steps need to be followed. Step 1. Divide the equation by a. So we have x squared plus b by a into x plus c by a is equal to 0. Step 2, we would be adding and subtracting the same term, that is b by 2a whole square from the equation. Step 3, we can convert this as a perfect square as x plus b by 2a whole square minus b by 2a whole square plus c by a is equal to 0. Step 4 would be converting this entire thing into completing a square method. Fifth step, where x plus b by 2a is equal to plus minus under root of b square minus 4ac divided by 2a. With step 6, we actually determine the value of x as minus b plus minus under root of b square minus 4ac as a whole divided by 2a. This is called the quadratic formula. This is how you can arrive at the quadratic formula if somebody asks you to prove how to arrive at a quadratic formula. So, next logical question is, what is a quadratic formula? Quadratic formula is the derived shorthand used to directly get the possible roots of the equation. In general, when no other method works, this method will work. It is important for you to memorize the quadratic formula, that is, x is equal to minus b plus minus under root of b squared minus 4ac and as a whole divided by 2a. I repeat, x is equal to minus b plus minus under root of b squared minus 4ac, this entire term as a whole divided by 2a. This is a very important formula for your scientific journey. So let's try to solve the same equation, x squared plus 2x minus 8 is equal to 0 with quadratic formula. Here we know that a is equal to 1, b is equal to 2 and c is equal to minus 8. So we have x is equal to minus 2 plus minus under root of 4 plus 32 divided by 2 as a whole. So, which is equal to x is equal to 4 by 2 or minus 8 by 2, which implies whether x is equal to 2 or x is equal to minus 4. See how simple it was to use the quadratic formula to arrive at the roots of x. Here, b square minus 4ac, the term in the quadratic formula, is often called the discriminant. So the next logical question is, what is discriminant? So the same quadratic formula can be written as x is equal to minus b plus minus under root of d, the entire term divided by 2a, where d is the discriminant. D is equal to b square minus 4ac. All we have done is we have substituted b square minus 4ac as d. The value of the discriminant can give us an idea about the nature of fruits. But why study nature of fruits? The study of the nature of roots gives us an idea about the roots and solution of the quadratic equation. Understanding the nature of roots is very beneficial. Just by looking at a quadratic equation and checking on the value inside the square root, that is b squared minus 4ac, one will be able to decide the nature of roots. So, how D decides nature of roots? If b squared minus 4ac is greater than 0, the root value will be real. So, two distinct real roots and two solutions will be possible. So let's take an example. X squared minus 5x plus 6 is equal to 0. So b squared minus 4ac is equal to 1. Roots are 2 and 3. So if b squared minus 4ac is exactly equal to 0, that is the second scenario, so two equal roots are possible and only one solution is possible. For example, x squared minus 2x plus 1 is equal to 0. Now, when we see b squared minus 4ac, we see that this value is equal to 0. So the roots are 1, 1 and solution is only 1. And the last scenario where the value of b squared minus 4ac is less than 0. In this scenario, there will be no real roots. An example would be x squared minus 2x plus 5 is equal to 0. If we see the value of b squared minus 4ac, the value is less than 0. So, there will be no real roots possible for this quadratic equation. This brings us to the conclusion of a very important chapter, quadratic equation. We made a journey from identification to solving to understanding nature of roots of a quadratic equation. I will leave you with the pointer that we discussed about quadratic equation. Quadratic equation has two and only two roots, but may have one or two solutions, and zeros are for polynomials. I hope you liked our presentation and enjoyed the journey. It is time for you to solve some more challenges and see what you have learned. Happy learning!